The calculus 202 example I have is for f of x is equal to 1 minus x squared. Find a formula for the Riemann sum obtained by dividing the interval from 0 to 1 into n subintervals of equal width and using right endpoints. Take the limit as n approaches infinity to calculate the area under the curve for 0 to 1. We must note that it is not requesting our interval be split into a specific number of subintervals, but a more general number n. Since it also mentions right endpoints, we have to use right endpoint summation. The notable difference between left and right endpoint summation is the starting index. To help visually represent our xi values, I will go ahead and drop that on the screen on our graph to the left. So you'll notice that our first endpoint would start right here. That would be x1. This would be x2. This would be x3. x4, and x5. But again, we aren't using a specific number of subintervals, so this is just an example of how we would if we were using 5 subintervals. Up top, I have included our right endpoint summation formula, our formula to find delta x, which is just the width of our rectangles, and I've also included the formula to find x of I, which is simply the right endpoint of the ith subinterval in a Riemann sum, and this tells us where we evaluate the function f of x in each subinterval when using the right endpoint rule. Now that we have everything we need to just begin the problem, we can start by finding the delta x, which is b minus a over n, which would give us 1 minus 0 over n, which is again 1 over n. Next, we could calculate x of I. So we have a being equal to 0 plus I of 1 over n. And we're going to multiply those two together, which then gives us I over n. Now that we have all the pieces of our Riemann sum, we can just substitute. So we have the summation starting from I equals 1 up to n of f of xi, so that would mean 1 minus our I over n squared, and we multiply this all by the width, and I'll just change that to our 1 over n. So then this would be our Riemann sum, and then we can simplify. One notable thing about summations is that there exist summation formulas that are almost, to me, kind of seem like identities. So I'm going to simplify this in a way so that we can kind of see how we get to our summation formula so that we're able to identify them. Now you'll notice in my next steps that the summations are gone. The summation from I equals 1 to n of 1 got turned into n because it was a constant. And then my second summation of I squared got turned into n times n plus 1 times 2n plus 1 over 6. Again, this is another summation formula. That was pretty easy to identify. The rest of my steps just simplify this out, and then I'll move on to my next step of finding the limit, and then we'll be done. To find the area on the curve, we will be finding the limit as n approaches infinity of the remainder of our Riemann sum. So that will be 1 minus 1 over 3 plus 1 over 2n plus 1 over 6n squared. And I don't know if it's obvious to you yet, but when you have n's in the denominator and your limit is approaching infinity, those automatically cancel out to 0, usually, because as your denominator is getting larger and larger and larger, your number is getting smaller and smaller and smaller. You're then left with 1 minus 1 over 3 minus 0 and minus 0, which then gives your limit to be 2/3, which also means that the area under the curve is 2/3, and that'll be your final answer.